Actually, in this talk, I'll present an open source that I developed for testing, built on top of Akka Http. It's well, it's oh, I see. It's this open source is something that I wrote. Yeah, and it has a very. It's a test kit. It's built to allow you to rest test very simply, and this is one of the things that in Wix we are. It's like every developer in Wix is using it on a daily basis. So we had one version that was written on top of the old one, the spray, which was the old Akka Http. And now it's a DSL that's built. I actually rewrote everything on top of Akka Http. On the first version that was out, well, at least that was stable and out, which was 10.0.0. It's a cool thing because Akka Http, I think, as a developer, we used to work very, very hard just to develop like minor servers or issuing requests. And Akka HTTP or Spray before it, you can bring up a server as like you do, I don't know, like you print to the screen. It's like 5 or 10 different lines of code. So one of the examples that I'll show later on is when using like my DSL on top of Akka HTTP, this is like those, let's say, 4 lines, and this is something that parses the requests and sends the response. This is an in-memory file server. So if you post a file to it, it saves it into memory, and then when you issue a GET request to that specific server, you will get what you submitted into the file server. Which, as a developer, this looks like magic to me, because bringing up a server in less than, let's count the lines, let's say 1, 2, let's say 20 lines of code, it's something amazing. This allows us, it opens the door to do a lot of interesting stuff, especially for our testing environments, because we, at Wix, we believe like, and I'll discuss a little bit later on, is that we believe that everything needs to be fully tested, and we are bending, like, we're doing whatever we can just to test stuff like very thoroughly before we deploy them to production. And things like that enable us to be crazy and stupid like we want to be, but not investing too much time in issuing those things. Like, yes? I'm sorry? My name. My name is Noam. It's not even... I'm an architect. I'm an architect at Wix. I've been working... It's... I incorporate... Because... It extends. It's built on top of Akka HTTP, and it's open source. So first of all, it's very useful for people who works with Akka HTTP if you're looking for samples, because one of the most difficult thing with Akka HTTP is that because it's so new, they changed the API a few times, and the API itself, like most of the example that I searched for was like all the samples in the internet are for version 1.0 something. And the API is completely changed since, and it's very hard to start to play with it because it's very hard to find the documentation. So for me, it was like, and once you figure out things to work with, the API keeps changing, not just the API, at version 10.1 that I upgraded it like lately, They rebuilt the connection management or the connection pool management. And first version, well, I was using the RC version, and at some point it just like threw an exception, and like the whole actor died or whatever, the whole infra. So everything is Wix is testing using our like Akka Http at the end. So what happens is once I upgraded everything, like a couple of projects builds were broken, and we had to revert this. So this is kind of like what you would expect if you would start to work with it. And I'm surprised that your guys are using it in production. That's interesting. No problems. At all? Which version are you using? Which version are you using in production? Yeah, which version? 10.0 or did you upgrade to 10.1? Ah, really? So it was out like, let's say, 2 months ago? So, yeah. Yeah. You know what the pitfall in TDD? Yeah, the pitfall is everything is covered and tested, but it's only tested against the things that you can think of. And the things that you don't think of, these are the things that are going to break you in production. So I'm also, you know, I'm stupid this way because I'm thinking, well, I'm covered. But I notice in some point, I notice like a false pretense, because this is why there are a couple of layers until we deploy stuff to production, because it allows people like me who does like to move fast and breaks things to protect us from ourselves. So, but it not always it works. So I see that more people joined, so I think we can start like the presentation or what I planned. Today we're going to talk about test REST services using Akka Http. My name is Noam, and I'm an architect at Wix. I've been working at Wix for the last 5 years. Been coding in Scala for I think like 4 or even 5 years since I joined Wix. Currently, Wix has centers in Lithuania, in Ukraine. We had an office in Dnipro, and we liked Ukraine so much that we opened another one here in Kiev. Vova is going to do another talk here, so, and also we have another talk here. And so we invest a lot in the Kiev office, and we're doing meetups, and so stay tuned. And if you're if you like Scala, we develop in Scala basically everything today. So Scala is the main language in Wix, and we're very. I think that for myself, when I joined Wix, one of the reasons that I didn't want to come to work with Wix is because they were working with Scala. And today I can't seem. I don't think I would ever work with Java. It's like I would prefer to work with whatever is possible. I'm actually, I switched to Node a few years, like last year, and I came back to Scala, but Scala is probably the best language. Anyway, so let's start. I want to start with the word synergy. Synergy is, as the dictionary claims, is building something that gives you more value from the sum of its parts. But it also comes from the Greek word saying working together. And working together is one of the things that we as people makes us better than other species, or we as citizens of a specific country. When we work together, then we can achieve a lot of things, bigger things that we could have achieved by ourselves. Even in software, when we build stuff in software, the things that we can do today is, if you would think at maybe like 10 years ago, things that you can do today on your laptop as something at like 2 days, there were like 40 people doing that back in the day. So the more that we invest in the community, the more we give out, the more we get back, and then we can do a lot of things. This is also one of the topics is Akka Http, something that enables us to do a lot of things that we couldn't do before that. So this is, and also in a project, as I'm working on a project, usually I build like another feature and another feature, but there is this point in a project where you write a specific couple of lines of code, and those lines of codes, when added to like the amount of work that you worked, starting to connect the dots from components that you wrote a month ago or a week ago. And at that point of the project, sometimes you just like write 5 lines of code, and it's so visible to the users, and it's so fun. It's one of the joys that for me to write new systems and write new libraries. But it all dwells down to integration. Integration, I think, is one of the most difficult parts that we have. Like, everybody knows how to work by itself, but once you have, you're writing a system, and that system needs to talk with 5 more different systems, joining them sometimes can be a pain. Well, not sometimes, most of the times. I think it's the second most difficult problem in computer science, right after naming classes. Naming classes is something that I'm still using default something on a class name. I'm looking for something with default, something service. It's usually my naming context, but I'm working on it. And today's agenda, what are we going to do today? I'm going to do a little bit of intro saying, to talk about Akka Http and REST testing and how we do that. The lecture itself will be divided in 2 parts. One of them is the client side, how we validate the system from the outside. And the other part is how do we develop external dependencies or server dependencies to other systems. And let's start. So I can't talk about computers or engineering without talking what is our culture when it comes to, oh, yeah, that's right. When it comes to developing software and developing new stuff. I think the most cornerstone of development in Wix is test-driven development. It's something that we do all the time. It's something that defines the team. There are various teams that doing different stuff, but everything is basically at some point written test first, and this is one of the most important things. And the reason for that is because we have this culture saying it's a DevOps culture, which means you build it, you maintain it. So when you deploy stuff to your production, if it doesn't work, well, you're going to wake up in the middle of the night and you're going to fix it. And if it's another team that databases broke down or something that it's not directly related to your service, no, you're not going to go to sleep until that guy would fix that system. And this is something that pushes us toward more coverage and more testing, because you deploy stuff and then automatically 10 million people are accessing it. So we have to have very high confidence in what we put out there. And also, microservices. I know that some people say, okay, microservices, that's a buzzword. But microservices is beyond software. It's something that defines the organization. So you have many teams, and each team has its own standards. And in the end, everybody needs to get along together. They don't always do, but that is choosing an architecture of microservices doesn't always. It's not going to say that your server is deployed in a specific way. It will also define how the teams are constructed and how things works in the company. I'll use a brief thing about like testing. How do we test stuff? You know the pyramids. Anybody doesn't know the pyramid here? Yeah, it's okay. So there are 3 types. Unit test is like basically the bulk amount of testing in the company. Integration is something in the books, there are various ways of how to define it. Mostly in Wix, we do integration. We call it integration testing, but it's basically E2E without using the client-side code. Some teams doing E2Es as well, and they actually test the service as a browser, with using a browser or a Phantom or whatever is possible. But those tests are not like the most common thing. But the thing that you need to know about this pyramid, it's okay not to know about it, is that the amount of tests decreases. So you don't test everything using integration because it's going to take forever. And basically not just take forever, because even if it would be easy or fast, it's still, if you issue a call and you get an error from somewhere in the system and you have to debug it, it's going to take you forever. You might as well, you better off having the error in the section that it's written into. So one of the things, when we do integration testing, I think the first thing, this is like the principle that defines a lot of things that we do. So we don't change the server. We used to do it, we don't do it anymore. So the server that we test behaves exactly as the server in production. We start it and we don't touch it. We only test sunny day scenarios. So if an API, we're going to test it, like it gets like 5 different parameters. We're not going to do for each one of them write a test for it. We're just going to do one of them, or one that covers the most amount of code behind it. But because later on, if we'll do it at that point, then you'll get too much tests to fix. And like I said, it's slower. Those tests are slower. They're usually sequential, because and there is no real solution for that. Because when you run a call and it interacts with another server on the other side, then it stores a specific state. So well, I wouldn't say it's not solvable, but currently our infra is not written. Maybe if we'll use more and more Akka Http on the server testing, then it's going to be better for us. But I'll get to it a little bit later. And what we're trying to do is validate the servers is working. It's working and it's expected, because some people say like, okay, I'm just going to do unit testing. It's cool, I'm covered. But if there isn't a single test that validates that those components talk together, then I think this is the untested systems. The only test that they have is a test that starts the server. It's usually when our legacy, like really, really legacy code systems, you have just one test that sees that Spring Context starts properly and doesn't crash, because you can have dead servers deployed to production. Happened to me. I'm guilty as charged. I know some of you wouldn't want to admit it on top of a big stage, but a little bit about REST testing, how we started. So the first thing that we started to use is Apache HTTP. It was written at some point in the dark days when we started as a company. When we noticed Spray Client, we immediately fell in love with it for a lot of reasons. We started using it in testing. So I wrote this library internally that was using Spray in various points at various things, and then at 2013, and they deprecated. Basically, they said there's not going to be a new version for 2.12. There is only going to be Akka HTTP later on. I completely rewrote that library from scratch. Open source from day one, and I built it on top of Akka HTTP. And when we moved to 2.12, the whole of our organization, every test, everything migrated to this, and our old code was deleted. I'm going to show you during this talk is how easy it is, and I hope that some of you may find benefit in using it as well. About Akka HTTP, or basically Spray, what we started, what did we like, what made us? There are like a ton of HTTP clients out there. There is async HTTP, which was called Ning, that we used usually in production as an HTTP client. There is also Dispatch. Anybody use Dispatch? Oh. Legacy. Yeah, it has some capabilities that Akka HTTP doesn't have, but the DSL is like, it's like writing stuff in Unix. I don't know, like piping, and I never understand what the lines like. They have like this going this side, right side, left side. I couldn't find any sense in it, but it's used, I think, in one team, the company. But what we liked at first, like the most thing that was obvious for us, is the model HTTP domain. Spray modeled everything in every header, everything very, very nicely, which was one of the first things that we saw and really liked. It has a great DSL. You can do like a lot of things. A lot of the things that I did was the things that I'm using are like approaches that came from Spray and Akka HTTP. So it has a very good and interesting DSL to learn from. And it's actually, I think, the most well-designed HTTP client out there right now. But it's my opinion only. It's fast. I'll show you later on a short demo. And like, I think Akka, like Spray before that, actually, I used to work in IBM. I was working for WebSphere. Anybody worked with WebSphere? So I was working on the server itself. Yeah, that's one of the. Yeah, I know. Some people wouldn't confess about that as well, but but anyway, back in the day when we had an application server, the application server was a big thing. You install stuff in it. There were people whose work with it was to design and to help and to maintain those application servers. Akka HTTP and the libraries today, at first it started with Jetty and let's say JBoss and Jetty, where we started treating HTTP as a library. It's no longer a server. It's just something that opens a port and listens to it. And I think this is the big thing that happens these days. It's like, you want to bring up a server? Okay, let's just like write 5 lines of code and you're done. You don't have to install a thing. I think I even had this is also a confession, but I had like an interview question that asked me to do homework, and they wanted me to install something on JBoss. And I never used JBoss, I only knew WebSphere. And I looked for like 3 hours in the internet how to deploy the WAR. Where is the panel to deploy the WAR files into JBoss? And there weren't any answers about it. And after 3 hours, I realized there is no such thing. I think this is the thing that I learned back then. If you're looking for a question and you can't find anything about it in Google, you're asking the wrong question. So the last line I can say about Akka HTTP is that it's not for production for us. I use Spray in production. We're not using it. We would want to use it, but I'll mention a few reasons why we don't still use it in production. But some of them, a lot of that is basically legacy reasons of when we start, how we start our service. So these are the side notes that I can say. Like a very good thing about Akka HTTP is that it has a very futuristic approaches. Everything is streams. Everything is non-blocking. It's really crazy, and it takes. As when I try to write code on top of it, I really had to adapt to all of those things. It's no longer just issue a request and get a response. It has a lot of layers to it, and it takes some time to learn and to get adjusted to it. But this is the future. I'm not saying it's not. This is the future, and if you're starting something new, I would say maybe try it out. But I definitely see the benefits in using this. The really hard thing is that it's hard to locate documentation. I think I mentioned it a little bit earlier, because every search that I found was for the old API, was really hard for me to, some of the things I had to really debug and find by myself. It's getting better. They're adding more support to it, but I think most of the, the official documentation is there. Yeah, but you know, do you read the whole documentation yourself? I'm looking for Stack Overflows. It's like, I have a problem, I want to see the solution. I'm not gonna, and yeah, I was forced to read the documentation various times, and also changes, by the way, all the time. So they're doing a lot of work, but it's not, every HTTP client, everything that you do, you search, you find like 12 different Stack Overflow. Usually you have like the answer directly there. And you get adjusted to it, you know, it's easy. We don't want to like read the whole book in order to use something. And like you said, it's brute force actually reading the documentation. You want to have like something more surgical. There are many pits to fall into, and I fell into, I think, I fell to a lot of them. I'm not saying there isn't any more, but I know that I caught a few of them. I had this issue with connection limits, that connection pool was depleting, and I had like tests that were multiple consuming of this of the stream, and then I got errors for it, so I had to reread and see it. And basically, working with I think 10.0.10. I upgraded to 10.0 directly to 10.1 RC1, and then everything halted in the organization. Like I said, I had to revert it. And those errors, like I could see I found the exact problem in the GitHub, in the issue, and they said like, oh, okay, yeah, we know there is some crash in this. We'll fix it in the future versions. And I was thinking, like, if I was using it in production, this is something that I would lose sleep over it. And they were like, okay, we're going to fix it sometime. So I'm not sure it's like, if you have like stability and something that you really need to deliver very, very fast, that wouldn't be my first choice. But projects being developed from day one could probably start with it, because it's quite amazing. And with that, let's start with like, what do we do? How do we validate APIs? How do we test stuff from the outside in? So the first thing that we want it to be is simple. Yeah, I know. It's easier said than done. Everybody wants, it's simple. But then I think there is this kind of thing where you get adjusted for things being complicated. It's like people looking at a specific code, and it has like 5 different things to define with like methods, and it doesn't work if you define this with that. And then you say, and they go like, oh, this like library is very simple. It's easy. And I was like, okay. And then I crashed like directly 2 minutes after using it, and they go like, oh no, you can't use those together. What do you do? Right. So when you look at any library that you write, you almost sometimes you fall in love with it, and when you fall in love with it, you forget how complicated it is. So I try to build it from day one as simple, and I spend a lot of time to make it simple. And I wound up with this. So you can import just a package import of something. There is also trait and object, but so you're asking if you want the synchronous one or the asynchronous one. You issue the call, you call get with the path, and that's it. Done. You can do a little bit more, but we'll get into it a little bit later. The only thing that you need to define right now is have like this implicit variable saying which port you're talking with. This is the client. This is how we test a get or a post or anything to it. But it's not enough. Just issuing a call is you need something a little bit more. So how do you actually create the whole request? This is something that came from Spray, and it manifested to us that building a request is a set of transformations. It's very functional, but it's very, very smart. Other HTTP clients also do that. For example, async HTTP, but usually they use it at one specific point, the authorization. you have the authorization interceptor or listener or whatever, and this is the only transformation that you have in the HTTP client. Akka Http and Spray took it one step later, and everything is built as a set of transformation. And you see how significant is it later on in building a lot of tests. The adding of headers and parameters is also done using transformations or helper methods. And that reason, what affects the code is that it makes stuff very, very reusable. So here is an example of how you build a request. So you have various methods. This is the same, this is another layer on top of Akka HTTP because it abstracts all the HTTP out of it. And you just state which parameters you're working with, which headers, and even payload, you just give the object. And there is, I'm not going to go into this in this lecture, but there is, you can supply an external marshaller that will marshal it into JSON. I have like tests doing marshal it to XML. When you work with Microsoft, sometimes you have to revert to XML. I'm sorry. but it also was possible. But look how simple is it to just create a request, and how reasonable is it to get the contract out of it. But the powerful thing here is that, like, for example, if you take it on top of it, if you build on top of those transformation, you can give them something meaningful in your tests. For example, if a parameter site ID is used to transfer a parameter or a header into the request, you can just say with site and bury the whole logic inside of it. And these things look like, oh, it's like, why would I do it? It looks, first of all, it affects the request itself. You can see get path with site, so people know exactly what this parameter do. But the most important thing is I have like maybe 50 tests that test something against a website. It's not something uncommon, right? And suddenly I realized that I called site ID, I had a misspell in it, and I called the site ID or something like that. Now to replace it, I have to go all over the code and replace it. If I'm writing stuff like this with transformation, then I can replace it in just a single spot. And I actually did it a few times when I said, like, okay, I'm not going to call, and the domain itself, it was first called instance ID, but then it said, like, oh, it's too overloaded. People can understand it. Let's call it up instance ID. Then to replace it and see that everything works, you can, if you built it properly, then the test becomes more maintainable. But like I said, we're issuing calls, and there's the contract. Like, I can issue calls. In Seinfeld, there is this episode where he tries to reserve a car, and she said, like, I didn't hold the car, but he said, like, you know, everybody can take an order, but the reservation is to keep the car in the lot. So we can issue a lot of requests very simply, but we need to validate that the request actually does what we expect it to do. So we have like a matches suite that's built on top of it. Who's working here with Specs2 and Scala test? Oh, great. Luckily for you, we did the both implementation for both libraries. Both have the same notion and things of how to do that. And actually, we worked exclusively with Specs2 with the weeks. I even have like lectures about how building custom matchers. And I had to convert everything to Scala test, and it's not so hard to switch from Specs to Scala test. It's amazing, but it's very, very simple. They're both actually doing the same thing. So anybody not familiar with matchers? Come on. So it's just a predicate used to write rules. It allows to validate the code most easily, and when stuff fails, it gives more information. Anybody using Specs2 might notice there is some way to do deep. If you're using b = 2, I don't know if you noticed that in the last couple of versions, you'll see a better error message handling. And it's partially a code that I contributed to Specs2 that allows you to show you exactly what's different inside of the object. So if you notice it changed, it's my fault. So how does Matcher look like? Well, it looks exactly as you'd expect. It would say, like, for example, if the response comes, you have various matchers for every aspect of the request. Status, for example, be not found or be successful. Received cookie, have the same headers, have any of the headers, have some of the headers. I invested a lot of time to do that. It looks very simple now, but or have body with a specific content, or with some object that does unmarshalling for you, or even content length. One of the things I noticed in Akka Http is that it start hiding headers from you if you ever use it. Some headers that decided that you're not allowed to see them, for example, content length, so they added a different set of things to handle them. But you know what? If you look at those matchers to understand the contract, it doesn't give you enough power, right? You need a little bit more. So most of the matchers are composable. So received cookie that, and then you compose a matcher into it. You can have a header matcher that will look for a specific header and look for that specific header for a specific content. This, for example, looks for a header with the name, and it's equal to val, but it could also do contain or something more complicated. So the matcher suites allows us to be more composable and be more declarative on how we write code. And this is the end of the first part. So we looked at how we generate requests and transformers, which is basically what I recommend for any issue of requests. But it also I also demonstrated how we generate matchers and how we validate the responses. But the client is not everything, as most of you are server people. So let's look at how we test servers inside it. So the most important thing that we have when we test a server is the isolation. We don't want servers to. We want as sterile environment as possible, but we also want to be able to run it on a laptop. So when we test, the first principle that also guides us is that all tests run locally on a laptop. I know people say, okay, we're like very advanced and there is internet everywhere, but there isn't any. If you fly, there isn't any, a lot of times where internet in the airport. So what happens if you want to work on a plane or whatever? The first requirement is that every test against the system needs to be run locally and doesn't issue an external call. What happens with other microservices that you interact with? So usually what we do is that those microservices export their contract in either an IDL file, or they actually give you a fake server that does everything against it. But those things run locally on your laptop. But there are also external services. Like I mentioned earlier, I worked with Azure, and Azure has an external server. Also Google, or a lot of services that you work with. What do you do with them? So, like I said, we're not touching the servers. We're just going to replace the configuration. So we can take the configuration and tell it, okay, bypass it. But that's not a good thing. We wanted to test that the request comes out and it's being really validated. So the first solution that like Azure gives you, or Google, or whatever, or the AWS that you use, they give you sandbox environment, which is basically a staging environment. I saw a quote somewhere saying, "I love my staging environment," said nobody ever. It's like, it doesn't work. But also, when you're using sandbox environment, it breaks the first rule that we do. The first rule is it has to run on a laptop, so it forces you to be online. And also, the test itself, it applies to the configuration. You just replace it instead. When you're running the tests, then it's going to, instead of talking to aws.com, it's going to talk to sandbox.aws.com, which is simple and convenient, but not at all time. Because the contract itself, it basically allows people who supply something like this to you to have a live contract. So if, for example, Azure wants to have you, I don't know, not send a specific header, then it can change it. If it sees that you abuse stuff, it can change it and then breaks your test, which is a good thing. But the problem is that, what the problems are is, like I said, it adds the online dependency, and it has to be available at all times. So this is another production system that they have to maintain, which is so much fun because now you have two production environments and not just one of them. Although one of them is a little bit less important, but I think it's more important because if you annoy developers, then they won't use your service. And it only verified when you run the build, right? It's like if you have a live contract and people update it and they go like, okay, now if anybody works here with payment provider, he knows what the pain of things breaking you in production. And even if they supply some sort of a test environment, then it's only going to be validated once you run the code. If you don't run the build, then the contract is not being verified, and you don't have any control over it. So what happens is that you revert to seeing those errors in production. So payment provider crash, AWS stops responding. Well, you'll see an alert first, and then maybe later on you'll see it breaks in production. So this is one of the reasons that I think that those approaches doesn't work. But it doesn't work, but we want to have something, we want to run them locally. Running them locally is not that simple. It's beneficial to us because it's just a build dependency. So inside the organization, if someone changes the contract, the build is being triggered, and automatically all the services who's using it going to be revalidated. It can also have different behavior. So, for example, if I wrote, let's say, it happens sometimes, I wrote a service, and that service gives other people to input some string into it. But then some client genius guy goes like, okay, I want to see formatting. So he adds HTML to it and adds a script. And then I get an alert from the security teams that my system allows code injection. So I'm trying to block it. And actually, it's a real story. So it happened to me once. And then I automatically shut it down in production only to get complaints from users that some stuff doesn't work. So if I'm building a test kit locally, I can have it have a different behavior. So in tests, it's going to break them in tests, but it's not going to break them in production. So it's kind of like a fair warning. You're doing something wrong, fix it right now. And once they fix it, I can continue doing that. So it doesn't have to be directly related to the code that runs in production. And it also allows to do chaos testing. This is something that sandbox environment doesn't allow you. For example, I can simulate a server that responds after 10 seconds. It doesn't happen. Well, you can support it, but usually people don't provide this. This is something that you can test allow people to test that your system is unavailable. Let's say if you have a very important service that's required for all services, and it's supposed to be always online. But what happens is, I think you said something about TDD, right? I don't remember who someone said. I don't know, you guys. But testing is very good. I'm covered. But it doesn't test that the server, yeah, I know. It doesn't test that the server is down. Or people don't think about testing it. I think most, like a lot of systems, breaks down as soon as the database stops to respond. So this is something that you can simulate when you write a custom server. So how do you create a server like that? It's, like I said, simple, right? Let's try to do stuff simple. So this is a create service. You import the factory. You issue a server. You said on which port it is. You build and you start it, and that's it. This is what it takes to build a server. By the way, you don't have to specify the port, because if you don't specify the port, it's going to be random. So it's going to be one line of code to start a server. It's like I said earlier in the talk, it's basically, I'm amazed that I see stuff like that. And I want to show you what it is to start a server. This is a part of the contract test of the library that I wrote. It's going to start validating stuff against the server. So this is the build. It opened servers. It opened, I think, and we're done. It opened servers, waited for them to be available, and query them. And it opened right now about 24 servers. And it took us, with other tests, by the way. I can do test only, but I didn't care. It took, what is it, 6 seconds? 6 seconds for 24 servers. I think it's a good deal. Wait a minute. Oh, yeah, I'll do. So I don't know if you noticed, but there are 2 types of servers that we're using to test, and they both have different approaches built into them. One of them is the mock servers. Mock servers is more something that needs to simulate a larger integration. It needs to simulate a service, a specific service. It responds, if you don't define behavior to it, then it would respond by 404. And it allows you to define that custom behavior inside of it. So this is an example of, I showed it at the beginning of the talk. I was supposed to be the big surprise, but act surprised. So anyway, this service is just, a handler itself is just a function from a request to a response. So what it does, it checks that the path matches, and once the path matches, it just handles it. This is, and if I'll show you the real example, as I showed earlier, where is that? No, it's on the same webpage. So this is the code itself. It handles the post. It just gets stuff from the URL to know what the file name is. This is an implicit conversion that I did that reads the data from the request. So it extracts the response as a byte. And then that's it. You're done. So writing something very complicated. It's I think in college I wrote a server that does maybe 1% of these things, and it took me a week. And I can just write servers these days. I have the Azure system. I could show you the implementation. I just realize what the contract is, and I have something that enforces stuff on top of it. And this allows my tests to run in a specific way. But building a server with a behavior built into it, it's something that is so simple right now that I don't see any reason why not to do that. And there is also the STUB server. So the STUB server is something that I built for unit tests. Yeah, you can do unit tests now. Well, it's basically component tests, but component tests against a server. So like I said, the tests that I showed you right now that opens 24 servers, these are basically my unit tests for that specific point. So you can do integration tests that takes 6 seconds to test all of it. So I can TDD and write something that works against a contract from Google or AWS, and that's just simulate the responses that comes from there. And it takes me really a small amount of time. It also have it responds okay, but it does something special that doesn't happen in integration. It records every request that gets into it. So those recording, and it also allows to respond with, it also allows you to program any behavior you want to it. So how do we match later on the response? There is also there is also a matcher suite that built into it, and this is an example of that matcher suite. So we have the server. The server received the request that, and then we have a set of matchers, specs2 and Scala test, that will allow you to validate anything about that request. If it's a GET, if it has a specific path, if it has the same parameters, if it has any headers, or everything that you can think of, you can validate using the matchers. And a matcher suite that really will empower you to do whatever you want with the contract inside. So, and in that specific scenario where you have a stub server, you can actually test like TDD and test that specific server that does every aspect of what you expect from the other side. So it also is, and by the way, you can always program the mock server to respond with 200 OK with it. It's the same thing. But the purpose is to build a server that you can, that will actually enable you to write the functionality into it. So you have a test that validates what happens if it responds with a 404. And so you can do like more of a small component tests with it. And the good thing is that you don't have to restart the servers every time. It doesn't take you forever. It takes you less than a second. And this is, I think, one of the great powers. So I'll conclude this part by saying that we run test servers locally, which is very helpful for us. Mock servers we're using to test very complex things. So writing the logic of an external server, something that if you look at the contract that you're exposing as a microservice, sometimes it's very simple. It can be like very, very complicated. Like for example, I built this media server that gets our file and then saves it and then serves it later on. The people who wrote the real server have like ton of concerns built into it. They have to be available, and they have to write it to database, and if the database failed, they do it somewhere else. And it's very, very complicated. But for tests, just to emulate the contract usually is a few lines of code. And it will enable you to do more thorough testing later on. And right now, with Akka Http, you can actually do unit tests or very quick tests on top of very small components, which is something amazing because opening Jetty used to be like a minute. And now it's 24 seconds, 24 servers for 6 seconds. And by the way, you can't get a deal better than this. Maybe Node, but... And with this, I'll conclude. And if anybody have any questions, I'll be happy.
Server with state.
Of course, this is exactly what I showed you. This server, let me open. If you can see, the state is stored here, files.put. I have a tree map somewhere here. Here it is, tree map, and that's it. It's going to store a state.
Thanks.
At the beginning of your presentation, you've said that, in your opinion, Akka HTTP is not a production-ready solution for now.
Not for us. Not for us, at least.
Okay, not for weeks.
Not for weeks.
Oh, so because Play framework uses Akka HTTP under the hood, and I know that a lot of applications use Play framework in production.
I think I actually corrected myself a little bit later on because I said that most of the concerns that we currently have, but is that we wrote a lot of our stack on top of older thing, which is Spring, and to move it to something as futuristic and new. We wish we could use Play, but it takes a lot of things once you build on top of. If you build on top of Akka, for example, it's going to be very difficult to go to another framework. So I'm not. I think that the thing that make it hard for me to use that directly in production is the lack of documentation and knowledge. I think there isn't enough usage in it, and when I hit issues. Usually, I was very baffled about the results. I couldn't find like really straight results right away. And when I'm using stuff like generally in the organization, and we have like 1,000 developers, and something breaks for everyone, and you have to find it by yourself. Like deploying, for example, I saw companies paying for Cassandra support, moving to the enterprise version, only for them to be able to ask someone for like answers because they couldn't find it online. So for me, that's kind of like a thing that I wouldn't put like mission critical services on it, but when you use Play, you don't use directly Akka HTTP. You use something that uses something. So you count on someone to build a sustainable framework for you. If it works for Play, it works for a lot of things, and you can use it. But using it directly, I really like to use new stuff. I don't think I will do it like directly. But like I said, it's new teams or new services. I go right ahead.
Okay, thanks.
Sorry, but I really didn't get why do you use mocks and STUB services? Because for me, if you have two interactive services, why not to create a client with all the functionality and then just inject the client and stop all the methods,
Yeah,
etc. You don't need other stuff.
First of all, I disagree, and I'll tell you why. Because this way you change the server, so you can count if the client itself not going to issue requests to the outside, you don't test that the request works on the other side. You're missing out one part.
This is a problem of client, not of your service.
What is the?
You should test client properly, but not your service.
But this is the way you test the client. This is the way that I test the client. So if, for example, I have an external server that you talk with it, so the external server that you talk to will give you the programmable server to test the validation against your server. So let's say, if, for example, you open a REST service and allow teams internally. For us, it's a little bit different because we're using different frameworks for internal communication. But let's say that we do that, and they misconfigure their HTTP client, or they don't set the ports right somewhere in the code. This would not be validated in the test environment, and this can happen, like in production, you can trip over it, and your service can be down. You can't test if you're messing with the point that issue an external call to another server. You cannot be sure that it works. I can say even more. You cannot be sure that it would work even if you start a server on the outside, because you can fall on other things. But it gives you more confidence. At least this is my opinion on it.
Thank you for your talk. First question is, who in Wix writes such tests? Developers or some QA automation
Developers.
engineer? Only developers.
Developers.
And
there is also an automation team that does stuff that tests like stuff like on bigger productions, but developers write all the time those tests.
And in this case, so it's a quite high-level test. Do you have in this case some threshold for unit testing and for integration testing, or you do not divide this and naming it tests in a whole and measure coverage some
First of all, yeah, of course, we call those integration. Usually the file name ends with IT and it tests the whole server. And there are unit tests that we end at T, so they are distinguished by nature between those two. What was the second question? I'm sorry, I just like
it was actually an answer. Yeah, and how often do you run such tests? Are they also run on CI systems?
So everything works, all of our builds work in snapshot mode. So every change, if you update a library, everything in the build chain will be built later on and retested. Mm-hmm. So if you change something and you broke it, then one of the services that's using you is going to break. Or hopefully, if you wrote the test properly.
Cool, thank you.
How do you manage the dependencies for that?
Currently, we're using Maven, but we're in the process of moving to Bazel from Google. It's we actually one of the top contributors on the Scala for Bazel plugin. So this is the future. But right now, yes, we're experiencing a lot of issues with Maven. Not just right now. I think just now it became unbearable. It was unbearable a year ago. I'm lying. I personally would use SBT, but it was this is what was decided.
Quick question. So you started your presentation with, you said like unit tests, integration, end-to-end tests, and then at the end you shown like, oh, you started everything locally, but then and you said like we test for happy path, but you also then mentioned like, oh, what happens if like it's 404, it's times out or something like that. Those are like negative cases, right? So, and they look more like unit tests, even though like you call them integration, but you don't depend on anything, and you pretty much integrate with your phantom servers, right? So how do you?
So this is exactly why I have those two implementation. One of them is testing stuff as a unit test. So yeah. I can move those kind of tests inside the server. So I'm going to test the client if it gets a malformed HTTP request, or something very surgical that I want to test about, like the contract that I have against.
You call them unit tests, right?
Yeah, I call them unit tests. So but basically, they're component tests, but I call them unit tests. That's correct.
Okay, but like, what are your integration tests? In your integration tests, you depend on what?
So the integration test in this case, let's say for example, I'm testing sending a push an email to an external system.
Okay.
So let's say the unit test itself going to test like a lot of things about the format of the email. It's going to reject it from many reasons. But the integration test will just assume that the mail passed and all the flow worked. Perhaps I'll add like one errorless solution.
I mean, email maybe it's not a great because it's like a fire and forget, right? Like, what about like if you have a server which need to call some external server and get response and do something with it, right? So, and then you call it, and then you have your local thing which starts like locally. You're faking this external thing locally, right? So, what do you call that, integration?
You know what? Let's keep this question for later on, but you can come. I'll show you how I'm doing it.
Okay.
Because I have like a perfect example. I'm actually having like a code
Thank you.
to show you.
Okay, so.
So thank you, everyone. Phil.